How's it going, guys? We're back with some Skyrim Papyrus modding. And yeah, we're going to be trying to sort out some of the bugs that we have and hopefully complete this. Alright, I think let's get rid of all these traces. Kind of know what's going on now. I don't think we need any of these. So the issue that I realized is trying to cast all of this as a float brought us a lot of issues. And I did a bit of research and it seems we can use modular to get what we basically need. Which is quite incredible actually. Let's put it, I didn't think of it before. Let's do this with thousands, shall we? To get the amount of thousands, if for example our number was 23,300, 23,300 modulo 1000 gives us 300 for the hundreds. So all we need to do to get the initial value, J can actually be an integer where we have the value divided by 1000. We should get 23. I'm gonna edit this, duplicate this, store the old one here. And J is just going to be the value divided by 1000. That should give us purely 23. We're not going to use fval. Why would we need to cast that as a float? So we're going to use int directly, the integer that we passed in. So that should work nicely for us. Divided by 1000 should give us 23, right? Then we can move on. Then the next part is getting... Let me grab this actually and bring it to the top. This is so much testing that we've been doing. Then K should be the integer modular 1000. The 23,300 modulo 1000 will give us 300, right? And K can also be an integer. So this should give us 300. So that's already 23,300, but now because we want to... I'm just wondering the output that I can actually do this in. What if I had just 10? Then I could just output as 10, even if it was just 1. This is an interesting one, but I think we can split it off like this. The amount of thousands, the amount of hundreds, and the amount of tens. I think I'm rather going to stick with it as I had it. So that's going to give us 300. Divided by 100 to get the amount of hundreds will give us 3. That's exactly what we want. And then obviously the last part being the tens, which I'm also gonna comment out. There we go. And this is also going to be rewritten, so that's going to give us that. And then if we do modulo 100, I mean modulo 10, that's 1,000. Yeah. So modulo 100. Why do I keep saying 100? Yeah, modulo 100 will then give us the tens, which in this case would be 0. But if it was, let's say, 23,310, it will be 10. So then we should get 23,310, and then obviously our ifs at the bottom are checking for that. So if L is less than 10, we're just going to add an extra 0 plus L, so we get, you know, double O. And then we don't need to cast as integers anymore. I'll leave that there for now. So that should theoretically, look how much more simplistic this is, instead of those like overly complex calculations. It's incredible. I don't know why. And I thought, obviously I had never worked with modulo before. And then did a bit of research, asked around, tried to understand how fraction worked. First it took me spending hours understanding how decimals worked. Understanding how numbers are actually formed up. For example, to get to the number 23, you'd use multiples of 2 or 1, since 1 is a multiple. Or 2 is a multiple of 1, sorry. So 23 would actually be 16, 4, 2, and then 1, which is 20, 22, 23. Which is incredible. You know, I just thought before 23 is 23. That's how you read it, that's how you add it. But apparently that's not the case. And then it's even worse for fractions, the way they're stored. As like, for example, 0.75, 0.50, 0.25, etc. So you have a lot of precision, but the moment you start going closer to a whole number, like, you know, where we had the issue with the whole 0.999, it's like, it's insane. Let's just put it that way. I really can't believe that we've literally nailed this down to just this, and we're gonna get the same output. That's incredible how that works. Still want to see how that works, obviously, but in theory this should be it. We can go and do the same for over here, which is int. Whoops. Should be int modulo 1,000,000 this time. No, it's just divide. Sorry. Just a straight up divide. Divide to 1,000,000. And then the next part. You can just have that there. Trace J. And J is literally just going to be int modulo. What is J? J is the thousands again. Let's take a number as an example. That should be 4,000, yeah? I think it's modulo 1,000,000. Not mistaken. Yeah, it's modulo 1,000,000. 1, 1, 2, 3, 4, 5, 6. That's for J. That will give us the 4. That'll actually give us 4,000. Is that what we want? How are we getting... That's for J. How do we get J before? Oh, J was just straight up the integer divided by 1,000. I don't see an issue with that. Just gonna test something obviously on my side. No, we actually need the first 3 digits only. So it needs to be that divided by 1,000, if I'm not mistaken. Divided by 1,000, yeah, that will work. So if our example is... take this as an example, then we should get 853, and here we should get 0. You need to be careful though, because then we're getting fractions again, 0.04. But I mean, because we're rounding it down, it will technically be a 0, won't it? And just to be safe, I'm going to put these in their own brackets and then just divide it by 1,000. And then the last part, we've done J. Oh no, we have K and L still. Jeez. K and L. K, what are we trying to get out of K? K is the hundreds, yeah? Can I just modulo from... Oh, because that's going to be 853, and that's going to be 0. Yeah, I see, we can't. We get the hundreds. I'll just divide it by 100, wouldn't I? That's essentially what I did above. I can't do 100. Oh, I can. It's so confusing. Wait. So we need to backtrack. L is tens. And I can literally just do int modulo 100 will give me obviously the tens. I'm being silly, I think. Yep, I'm being silly. We can still do a modulo 1,000 here. Or hundreds, can be exact same. And then just divide it by 100. So the code is the exact same. That's pretty cool then. The integer divided by 1000, sorry, modulo 1000 divided by 100. Because otherwise, okay, so k is always going to be the same. K is just going to be int modulo 1000 divided by 100. Because otherwise, if it was 640, for example, we would get 640 when we only want the 6. So divided by 100, and the game will automatically round for us. So again, our example, this is going to be 0. And this is going to be 40 at modulo 100. Cool. So now that we've done the modular, I think we're ready. So in our case, that would be 40. Am I missing something? That would be 0 for hundreds. Obviously, that's the hundreds. 0 to 9. 0 to 99 is the tens. The next ones is the thousands, but the thousands can take up to 3 digits. And in this case, that will be 0. And then obviously the next 3 are the millions. So now that the code is exactly the same, do we need... Oh yeah, we do need to know if it's millions or thousands, because otherwise the modular code would be a bit different, wouldn't it? So I think we're ready actually. This is it. And we must just change L to an integer as well, and I to an integer. Then let me just make sure. $45. So I'm just doing calculations in my head. Okay, there we go. So we're not going to use fl anyway. And we can change INT. We're just going to use INT. I'm so excited for this. We technically don't need any of these, do we? J less than 10. It's so nice not having to cast either. INT and INT. There we go. Let's go and compile that real quick and go test it out. See what we get. We failed on line 181. Issue in 182. 181 and 182. Ah, okay, I see what's going on. And here we just need a modulo, we don't even have to mess around anymore. So it's INT modulo 100, give us 10. Wait, we don't want to divide it by 100, that's where we're gonna get an issue, aren't we? No, we won't. We're fine. Cool, let's go compile that again. And we can jump in and test. We got no errors. Okay, that should be it. Let's check our test case now. Right from the start. Okay. Interesting. $800 returns 800, 1000 returns 1000, 1001 returns 1001. It's awesome. And here you can see it's 1, 0, 10. Love it. So far no issues. Wow, it's incredible. Huh, it even works for the larger numbers. Do you guys remember how it would like truncicate in Q8? Was that right? That number at the end? And now it's gone. Displaying as it should. Wow. Look at that. This is incredible. So the only issue that we have that I can see is when the number is exactly 0. If L is less than 10, 0 would be here. Should we do a less than 10 but greater than 0? Is that too much code? If L is less than 10 and greater than 0? Because that's essentially what we need. Because then it's not going to add the extra zeros, where it's the only place that's having this issue. I mean, it's either that or an extra else if with an extra line, right? Which is not what we want to do. Let's go remove those extra traces that we don't need. We don't need FL anymore, do we? They're completely phased out. Awesome. So I'm gonna go and phase that out. If it's less than 1,000, we obviously still need our hundreds and our tens, but if it was 0, I mean, do we... I don't think we should specifically add a case for 0, should we? Because it also affects... And you wouldn't display a number 03, would you? You would 1, 2, 3, 4. Like, you're not going to say 03 XP, it'll be 3 XP. And we can always add padding afterwards and stuff like that. Yeah, so for now, let's just... And then we need to add a case for... billion, because the max integer value. I wonder what it would display right now. So the formatting would be... Is that greater? B is billion is true. And then we basically have to duplicate this code. Oh man, we're gonna need an additional variable, aren't we? Because I is a million. Now I'm wondering if we should change all this so it becomes I millions, I thousands, I hundreds, I tens. I think that's gonna be better. Because then you don't know what K is, then you keep looking. K is hundreds. Hundreds and tens. Hope we don't mess something royally up now. So that's thousands. Then we need K and L. That's J, I hundreds, I 10, whoops, and then I millions, really? I hundreds and I tens. That goes there, that goes there, that goes there, and that goes there. Perfect. Thousands, millions, billions. This will be easier to read as well. This is for the tens. Whoops. Wait, this was J. What was J before? K L. So I'm so glad I'm doing this. It's J. J is thousands. Pretty sure, right? Yeah, J is thousands. It should have made sense with thousands. And I10s is greater than 0, 10s is 0 plus I10s. We need S billions plus S billions separator plus S millions. We can add another one. So that's for a million. And that's for a billion. There we go. That's perfect.
Fast forward a year or two, friends have changed, but so can you. So can you.
Okay. So now that we've got the string ready, we should be able to output that and test it out. Let's just make sure if we're over a billion. Oh, we still need another one. I billion. Did we add I billions? I'm sure we did. Did we? Oh, we didn't. I billions. There we go. I'm just going to specify billions. That is 1 to the limit. To the integer limit. Which in this case is 2,147,483,647. Do I have to specify that? I'm sure I'll know exactly why. Because obviously int32 only go up to 2 billion. And we kind of need it, even though we're only ever going to use it like twice. But it's fine. least we got it in. Cool, so how is billions gonna work now? I think billions is gonna work the same way as millions will, except that we're gonna use modulo a billion. Oh, we're just dividing int by a billion first. So let us get our string. It's this one. Let's remove all of that. That's our number. Divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. That will give us 2. So that should give us 2. Then the next part should be int. What do we need? We need the 147 million. Let's see how we get that. Can we modulo a billion? Yeah, that gives us 147, 483, 647. What if I modulo a million again? I just realized something. Then we get 483,647. What do we need? We needed 140, okay. So we need the 147, so we need it divided by a million. So millions is gonna be int modulo a billion. Okay, and then divided by a million. That should give us the 147 that we need. And now that we have the 147, we need to move on to the next part. So we got 147 million. We need the 483,000. Let me just trace out billions so we know what's going on. So the next part we need are the thousands. So if I do modulo a billion, we get 147 million. But we wanted the... what did I say? The 483,000, right? So modulo 1,000 after... modulo a million, sorry. Should give us what we need. So we should literally be able to do int modulo a billion modulo a million. That will give us 483. No, that will give us 483,647. So we're still gonna need to divide it by 1,000, the end result. Which would then have given us 483.647, but because it's gonna be rounded, we're gonna actually get 483. Ooh, there's a lot of steps. So we got our 2 billion, we got our 147 million, We got our 483,000. Now we need our 647,100. I feel it should basically be this, shouldn't it? And then just divided by 100, same as above. Divided by 100. Wait, I think I'm being silly. We needed what? We needed the 647. Okay, there it is. I don't know why I went that route. It's actually really short. It's just a number modulo 1000. I don't know why I went there. It stays the same, it never changes. And then just divided by 100 to get the amount of hundreds. Which would then be 6.47. But since it's going to be around it, it's going to be 6. And then this stays the same. It's an integer modulo 100. So integer modulo 100 would give us 47. If only it was that easy for hundreds. To get, you know. So that's 40. So let's just check. That's 2,147,483,647. Sorry. Whoops. What did I just change now? 647. That should essentially be it. 4 billions. Now, can we shorten this? I don't think we need to modulo a billion, to be honest. We need to get the 147 part out. Wonder what happens if I do... Oh, we need to unfortunately do a billion. And then divide it by a million to get 147. And this unfortunately has to be the number divided by a billion to get 2. Yeah, so this seems to be the quickest way to get it. Thousands? Why are we doing it like this? To get the 483. We only need to modulo by... Why would I have done it that way? Strange. I only need to do it once. That was a bit silly of me. We just need that. So modulo a million. Divided by 1,000 to get to 483. Yeah, so this is the neatest. 100 stays the same. Thousands is always the same by modulo by a million divided by 1,000. And millions is always going to be the number divided by a million. But can I actually do that? Oh, that'll give me 2147 though. So modulo a billion is giving me how many millions? I mean, I guess we can do it that way. There's no harm in doing it that way. Cool, we're ready to test. Now I just need to make sure the checks. We need S billions is equal to I billions. $147. What if it was 1 million? Ah, we need to do the same, I think. Let me just test first as is to see where we stand, and then go from there. Let's take that maximum integer value and put that there, and we're gonna change this. Let's do another one. Can I have 1,006, 007, see how that goes. Kind of have a feeling of what I need to do, but I just want to make sure first and foremost. Let's go and compile that. Let's go and compile our API. And let's jump in.
The seasons come and go like thoughts of you. Like a wave returns to the sea, into the blue. They change but in a cycle that I can't lose. Each painful but delightful to live through.
Cool. So we're not too worried about these. These obviously pass fine. Actually, this doesn't pass fine. And these are still millions. Interesting. So we need to sort that out for the extra padding. But let's see, for the billions? Hey! We kind of knew that would happen, because we didn't add the padding. So there needs to be a 00 there. There needs to be a 00 there. Interestingly enough... How does it work with 007? 007, that's funny. Oh, we technically don't need if it's a billion else do this. We just need to do like what we were doing for tens and hundreds. Right. And then we're already checking here. If it's less than... Ah, I'm so silly. So let's do I hundreds. Hundreds go from 0. Let me just figure this out in my mind. Hundreds go from 0 to 9. So if I hundreds is less than 10, oh, it should just be exactly the same as above. And greater than 0. Then we're going to say I hundreds is 0 plus I hundreds. Want to visualize this? Oh, we don't need to do anything for hundreds. Yeah, we don't need to do anything for hundreds. That's only part of tens. Yeah, because hundreds are always just going to be 0 to 9. So we don't have to worry about hundreds. It's thousands that we need. So I thousands less than 10 and I thousands greater than 0. So let's say 001. We need 2 zeros. So to be 0. If I thousands is less than 10 and greater than 0, but we need another check here first. If it's less than 10, meaning it's 9 or 0 here. So 1 to 9. If it's 1 to 9, like it is here, we need 2 zeros. It needs to be 0, 0, and thousands, which is 1 or 9. Else if, and we do the same as above, except we're checking if I thousands is less than 100, meaning it's 99, for example. And I thousand is greater than, what do we want it to be greater than? Greater than 0. No, greater than... Greater than 9, because it's going to be 10. So it could be 10. So do I do greater than 9 or do I do greater than equal to 10? I think this is nicer than doing a greater than 9, even though I know that saves me 1 character, but fine. We're going to do greater than 9, which is 10. less than 100, more than 10. Then I thousands needs to be 10 plus I thousands. So 010 or 099 in this case. And we need a final one, else I thousands is just so I technically don't need an else here, because if it's else and it doesn't match this if, we're already setting S10s to I10s anyway. So this is redundant. And we don't need an else here. I just realized it has to be S10s. Sorry, S thousands. There we go. S thousands is equal to 0. S thousands is equal to 0 over there as well. Cool, so that should be it. And I'm going to be able to comment this out. And there we need one for millions. So let's get an example going. Same as here, so we're going to have 001. Because we had 1 million. Oh, only if it's a billion though. That's the thing. I see where the issue comes in now. Because if I do it straight up like this and you have 1,000, I thousands is going to be 1. So it's going to be 001. So we technically still need the if million. So we need a if B. What would count? B is billion. It's either or. If it's a billion or a million, then we know our thousands need the 00 padding, because if it's a million, you can have 1, 001. So we need to make sure if B is billion, B is a million. Then we don't even need that check. We just do S thousands. We don't even need the check. It's just automatically. Oh. You would have 0012. Okay, no, we still need that check. We can do end if here. Well, actually no. Gonna end if here. That's only for a billion and a million. Otherwise, S thousands just remains S thousands, which is 1. So the only one we really needed was for tens. Hundreds stays the same. Tens. And then we need millions if there's a billion. So if B is billion, then we're kind of going to have something like this. If it's a billion, so like this, and we have something like this, we have 1 million, then we need 2 padded zeros. If I millions is less than 10 and I millions is greater than 0, then S millions is 0, 0 plus I millions. We need to pad that 0, 0, if that makes sense. Else if I else if I millions less than 100 and I millions greater than 9, which would be I millions is less than 100. If it was 99, is that what you mean? That's a million. That's 99 million. Yeah, then we just need S millions is equal to 0 plus I millions. So 0, 99. Cool. So if billion, obviously. And then if a billion or a million, then thousands need to obviously be padded. And then tens obviously are always the same. Doesn't matter if it's a million or a billion or whatever, due to the fact that we obviously add up hundreds. Cool, so that's nice and neat. Let's go give that a try, and that should resolve the majority of our issues. Quickly go and compile that. Okay, let's jump into the game. Hey, Pomelo. Where'd my Pomelo go? Yeah, close it. Look at it. Oops. Did I? No, it's still there. Losing my mind. There we go. So let us check the bases. Still getting 0.3 there. I'm gonna sort that out. We're getting 80 there instead of 800. Okay, when it's triple zeros. Okay, something went quite bad somewhere. But we'll figure that out. Why is this happening? We have this number. It's 853 million. If B is billion or B is million, which it would be, if thousands are less than 10, are the thousands less than 10? We have 0. Oh, okay, I see. So we need a case where if thousands are exactly 0, we need triple zeros then. So if thousands equal to 0, then S thousands see, it's exactly as below. The only thing is if I didn't remove greater than 0 and I just left it, then it would be 0, 0, 0. Okay, I see where the problem is. So all I need to do, actually I don't even need to do this. I just need to say if it's less than 10. Pad it. Problem solved. And if the millions are less than 10, pad it with double O plus 0, because if it's a billion. Else if millions less than 100, is this the same issue? AKA 99. Why must it be greater than 9? What's the logic of that? So if I had at 9 million, no, I don't need the greater than 9. I don't know why I added that. Just do less than 100. So we do less than 100. Then we pad it with 1 0. And if thousands are less than 10, we add 2. If thousands are less than 100, add 1. Keep it simple. So that should solve that issue. Now why are 600s showing as 60? Why is this an issue now? $600 will show as 6. If 10s are exactly 0, oh, we need the same. Oh, okay, I get why. Because we're trying to solve the other issue by doing greater than 0. So why didn't we do if I10s, right, equal to 0, then S10 should be 0 plus I10s, right? It should be 0, 0. If it's exactly 0, it needs to be 0, 0. Then we do else if I10s are less than 10. We don't have to now worry about it reaching 0. because if it was 0, it would be 0, 0. So we are assuming I10s is 1. In this case, it needs to be 0, 1? No, this is now we worry if it's hundreds. Because we can't have it 0, 1. If I10s are less than 10, it's going to be 0, 1. But we don't want 0, 1. Because then, if your number was 810... No, well, 80... Oh, okay. What if your number was 1, for example? Then it will be outputted as 0, 1. So I10s... Why are we doing that? It should just be if it's 0 on the dot, then it should be 0 plus I10s. I'm getting somewhere, I'm just trying to think past this mental block I'm having right now. If the number itself is 9, it should just return as 9. If the number is 909, we need that extra 0. Oh, okay, so we need if is hundreds. B is hundreds. So where are we checking for hundreds? This is hundreds, there we go. So B is 100 equal to true. There we go. So that's finally going to be used. So then we need a if B is 100. And if I10s is less than 10. There we go. So we can do that. So if we know it's 100 and 10s are less than 10, so we add 0 plus 0. So it's 1, 0, 0. There we go. We just leave that by itself, technically. That's for millions. That's for thousands. And this is if it's 100 and the 10s are less than 10. This is actually still an issue. This should be for B. Technically B is billion, or B, because it's gonna, you're gonna have the 10s in all of them. So it needs to be covered for billions, millions, or hundreds. Billions, billion, million, billion, million, hundreds, tens, millions, thousands, tens. So 100 will never be an issue because we're only going 0 to 9, which is really nice actually. Okay. And then if I10s is exactly 0, we actually don't have to worry about this now, because that should be covered. Because if I10s is less than 10, it's gonna pad it to 0, 0. So all we need to worry about is... Wait, do we have to worry about anything? No, because I10s is either gonna be 0 to 99. And the only time it's an issue if you have 100 and I10s is less than 10. So technically I don't need a section for I10s. Besides obviously this if check. That should be it. And then we're doing if the integer is less than 100, hundreds will obviously be empty. Cool. Let's go compile that. And that should hopefully be everything. No. Okay. How does that look? Start from the beginning, shall we? Should return 0, we get double zeros. Okay, we all sort that out. Should return 3, we get 0, 3. This is otherwise right. That's not right. Should return 1,000, but we're getting 1, 1,000, 0 hundreds, and 0 0. So we may have needed this if I10s is 0. Oh, we're missing thousands here. Silly me. B is 1,000. We need all 4. We just didn't need one for 100. Will this solve this issue? Because if it's 1,000 and 10s is less than 10, we add a 0 plus 10s. Yeah, that would have solved that issue. Okay, but now can we figure out why 0 0 is coming out as 0? 0. When I10s, 10s is I10s, which should be 0. Should be blank. And 10 should be 0. B's 100 is true. Oh, because we set this as 100. Then I10s would be. Okay, so there's an easy fix for this. We shouldn't be if int is less than 1,000. Or it should be less than 1,000, but it should also be if it's greater than 99. Wait, so we just need another if. If int is less than 100, then I10s is going to be INT. Literally just like that. So if we came in with 99, you will go with 99. Else, if it's less than 1,000, then obviously we go with that. Hundred is true, 100 is... You know, I'm worried to say this is it, because the amount of times I say this is it, like... I'm missing a right parentheses, 448 and 483. 448... Oh, that needs to be an else if. Wait, so we technically don't need this again, do we? No. That should hopefully be it for the 100th time. And we need a 476. What am I missing? Missing something. Oh, because we have a if instead of an else if here. There we go. Okay, that compiled. Zone 41. Okay, let's see how that ended up working out for us. So 0 gives us 0. Good. 3 gives us 3, 17, 25, 800. 1000, 1001, 110, 1103, 9050. 10,000, 17,003, 23, 300. Remember that one. 99, 999, which is perfect. 900,000, 999,901, 999,999. Not even going to read these numbers anymore, but just matching them, they so far look good. Up to the millions now. So we can basically, do you remember like we were gonna limit numbers and like do it like something ridiculous because apparently it's inaccurate. God, imagine I sent an email to Bethesda. I feel like a complete idiot. Be like, there's something wrong with your math library. And we'll just like laugh and be like, learn to do maths. So yeah, we managed to solve that issue. And the test cases are all passing. I don't see any issues. I could probably add like an if statement where if this does not equal that to just highlight it. But I mean right now manually seems to be, you know, I can even generate random numbers for the test cases. Like how cool is that? So this works 100%. Look, up to 2 billion, literally the max, from 0 to 2,147,483,647. Now this is the interesting part. How is it going to return? Let's try giving it a value that we know it can't return. It can't return this because it's a max value. So let's try that, and then what I want to try is a negative max value. We're going to do negative 2147483,647, and let's see how it handles that. We're not going to obviously have the negative sign, so symbol, whatever you want to call that. So we actually have to add that. We need to add a check for that actually, now that I think about that. And then it should be able to handle negative numbers. These numbers just negative forms. What else can I think of? And then I wonder if we should do some stripping and stuff in terms of checking if the number is actually a number. So we can check if it is not an integer, just be like, sorry, you done fucked up. Apparently the bot thinks I'm offline. It's great. It's great when your own bot throws you under the bus. Thanks, bot! It's actually going to be interesting. I wonder what it's going to return. I think it's going to return the max value of that integer in negative form. I wonder if we need some error handling for that. Let's see what we get. We even compile that? I don't think we did. Oh, it's the freaking API that I had to compile. Obviously it didn't work. There we go. Let's go try again. Cool, that should be it. And what do we have? Okay, so should return 2, 5, whatever. Okay, that's the max integer value, which is good. So it seems somehow it converts it automatically. We don't have to worry about that. Or maybe we can worry about it, just in case. And then as for the negative one, we get -2, 0, 0. Fucking hell. Just don't give it negative values. Why would you need it anyway? When would we ever need to return a negative value? I mean, you might as well, right? If we're doing positives. Yeah, how do we solve that issue? -2 billion. 0, 0, -147. It's adding 2 zeros there because for a million, is that a million? Yeah, that's a million. Let's go check our code. I think we did something there. So if million, where's if million? If B is billion, there we go. If millions are less than 10, obviously it's going to be less than 10 because -147 is less than 10. We need to check for and greater than -1. I think we just need an entire if statement for all of these stating surprised that actually works. Oh, an absolute value. And it exists. Abs. Let's give some abs to our integers. Let them work out. So absolute exists. So that would flip 5 to negative 5. No, I mean negative 5 to 5. Huh. Okay. So we just need abs. So abs is the function. It's a math function, absolute. So we need to pass our number in as absolute. So how do we do this without rewriting our entire code to have a section for positive and negative? Why don't we just ABS them anyway, because this shouldn't change it. 5 should remain 5. It's just negative 5 will be 5 as well. So we could just do ABS. The only problem is how do we deal with the obviously less than 10 for the negative values, because it's still going to add 0, 0. Even if you add negative 3 million, because of how this is, okay, I think we got our work cut out for us. I think I got it. So let's have if million less than 0. That means negative. Then less than 10. That's going to be the negatives, obviously. So then these millions end up becoming absolute. Sorted. No, but what if it's negative 483 million? Oh, then it's just going to become 483. What if it was 0, so 50 million? It's going to be 0, 0. I know we can do this. I just figured it out. I figured it out. This is actually brilliant. Just do absolute on the numbers. For all of them except a billion. So we just do ABS I millions. It will return exactly the same for positive numbers. But for negatives, it will just flip them. So negative 10 will be 10. And then because we have the negative number in I billions with the minus, it will be minus 2, etc, etc. So we just do ABS on these. And that should be it. Let's hope it doesn't need me to cast it as a float, because ABS takes an input of a float. Let's hope it doesn't mess anything else up, but let's see how that goes. No problems? Cool, that worked. I'd rather do the ABS outside of all those calculations. Let's do I millions equal to I millions and we're going to do SI thousands and I hundreds. So millions, thousands, hundreds, and we also need to do tens. Whoops, I tens. Wait, why am I doing this again? I could just leave it like this, can't I? Oh, because then when we get to this point we wouldn't get the plus I millions, even if it was negative. So we need to leave that as is, and then instead of calling absolute here we just call I millions, etc. No need to cast it again. There. So billions, millions, thousands, hundreds, tens. There we go. That should solve it now. I'm getting a type mismatch here when we're trying to do this. While assigning to an integer, cast missings or type unrelated. Where it was fine earlier. Seems like we're gonna have to add them to the final value after all. I think it's because I'm trying to assign it to itself and referencing itself. So that's not going to work, unfortunately. Oh well. Let's try... That should work. Hopefully. Now we're getting a type mismatch. That's interesting. Because it returns a float value, doesn't it? Yeah, because it's a float. Okay, so there might still be hope for us. Can I just do as float, like that? Let's see if that works. No. Oh, we need the output to be as integer though. There, that worked. Boom, 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 boom. Let's hope that doesn't break anything. That's what we have our test case for, and that compiled successfully. Alright, let's go. So nothing should technically change for positive integers, but for negative ones they'll just be flipped. Let's check now. That's fine. Let's go to the negatives. There we go. Negative 2147483647. It returned. Exactly as it should. I do see there being an issue though, which I'm going to rectify now. Obviously we're counting on the billion to have the negative integer. Whereas what if it was negative 100? You wouldn't have the negative, you would just have 100. Which is obviously not okay. So let's add some test cases for the negative values. Let's do the same. Should return 0. Negative 0 should return 0, I think, right? Let's do 800. And let's do this one. It's just a few of the gotchas. Oh, we already got that one. To the 9050. How about that? Okay, so let's just turn these negative. Boom, 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 boom. Boom. Okay, so we got our test case ready. Let's make sure to actually compile the API this time. Okay, API is ready. Now let's go and create support for the negative. And I think the easiest way we're going to do this is right from the get-go. We're going to go if int less than 0, meaning it's negative. So all negative values. B is... Did we say B is negative? Is that what you call them? Negative values? Negative integer? Okay, so if the integer is less than 0, all negative, b is negative equal to true. And then we need to make a boolean. B is negative. If it's less than 100, b is negative is true. How does it treat it as... This is interesting though, because somehow it treated that value as that value as billions, because obviously it got through the relevant paths. So all of them should land up here now. So I've kind of shot myself in the foot, haven't I? So this is actually where I should set the values as absolute. So you know, I just found an even better way to solve our issue. If we know that it's negative, now we can do int we just do absolute int. So we change int to absolute int as an integer. And b is negative to true. And then we end the if here, because then it's going to go in and it's going to check if int is less than 100. Cool, now that we know that, so we just say s negative sign equal to that, yeah? Then what my plan is to add s negative sign right in front of it, okay? And then we just have a simple check where if b is negative, or sorry, if not b is negative. So if it's not negative, then we just have s negative sign equal to blank. So we overwrite the negative sign so it doesn't have a negative sign to begin with. So that way we only have one string output instead of having to add an if statement and, you know, duplicate the code. So if not b is negative, negative sign is blank. Otherwise it remains. The only issue that I see here is negative 0 is going to be 0 No, it shouldn't be. It depends on how the game handles -0. If -0 is still 0, I mean 0 is 0 technically, right? So -1 should be the first negative. But then again you have... Yeah... What about fractions? That could be negative, because you can have a -1. I'm sure you have negative fractions, but those will still be negative fractions. They wouldn't be -0. So 0 is 0. And then you find out that's not the case. Type mismatch while assigning. So 184 and 462 have issues. 184 and 184. String S negative sign. My bad. And what other issues do we have? No, that's solved. So now that we're doing that, that means all the way down here, where we are literally changing every single value, we don't need to do this anymore. Because we literally take the entire value and flip it. And not have to... Oh, I love when I learn things as I go. It's brilliant. Okay. Cool. Let's give that a try. Okay. So we got all the positives. Nothing changed there. So that returns the overflow value. Cool. 0 should return 0. Did I add a negative to that? I didn't, did I? Oh, that's a pity. Should return... Oh, no. It should return 0. Because we entered -0. Okay, perfect. So -0 is 0. Thank you. Should return -3. We got -3. We got -17, -800, -1001, -9050, -999, -999, -601,001,984. Okay, so we snagged upon our first issue. Everything else was going great. Until we got to wait, is it me? Might be me. No, it's not me. Okay, so something happened. For some reason. 601,002 became 601,001,984. So absolute of 601,002. Let's try get the absolute value of this. No. Absolute of 601,002,000 should have returned exactly the same value. So something went wrong. Interesting. Very interesting. We still have that issue. And why is that an issue? Now I'm wondering, did we compile? We did compile, didn't we? Yeah, we did compile. Oh, so we don't have two negative signs. How's a billion just getting through? Are you telling me that negative a billion somehow is not negative? No, it can't be, because else we wouldn't get the double negative symbol. So we flipping negative. So the maximum integer value as a negative is 2147 483 648. So we got 648 there. Do you see that? Oh, you know what happened? When it flipped it, because negative 647, I guess, becomes 648. It basically overflowed. Oh. Okay, so we cause an overflow. So we need some kind of direct comparison, I guess. Now, how is it possible that every negative value is fine, but the moment you get to 601, 002, it worries me that it's a float though. So we need a direct comparison where if int is negative 2147483 we have to manually set this, don't we? What a mission. We need billions, millions, thousands, hundreds, and tens. We have to manually specify. 2 millions, 147, 483, 6, 47. So that should resolve that issue where it's overflowing. Still want to figure out why this is happening. Is this another rounding issue with float values? I have a feeling it is. It actually makes perfect sense because floats are only precise up to 6 decimals or like 6 digits. And this is obviously more than 6 digits, so I think that's what's happening. It's a freaking float again. The float is back to haunt us. So, that means we have to go back to our old plan. Where we still track if it's negative. But we don't change the int value. Because that's obviously what's screwing it up. And thankfully I didn't remove this. So we just toggle this. Millions is millions as an integer. Thousands, because then obviously you're not going to have an issue with precision, because this is a max of 3 digits, 1 digit, 2 digits. You see, so that's brilliant that we worked it out that way. So let's go give that a try. So technically it should solve this issue, and it should solve the fact that this is inaccurate. Yeah, so there's many funny stories about float values. I mean, they were responsible for many spacecrafts crashing, or rockets if you want to call them, because, you know, you obviously have to be precise to the last decimal when it comes to calculations. Because I mean, it is rocket science, and so many of them crashed because the trajectory was off by 0.00007 of a decimal, whatever the case is. So that's the thing. Thankfully we're not trying to go to the moon in Skyrim. Okay, let's see how this ended up. Oh, we're still getting 984, that is... At least this works. We did solve that issue. -2 147 483 647 does show us -2 147 483 647. So that's at least good. You know, I just realized something now. These numbers aren't being formatted. I just realized that now. They're not being formatted. Why? And this still has an issue. How? Millions is millions. Millions would have been what? 601? Just flip 601. And you get 601, no? I just realized another thing what's happening. It was never getting into the function to begin with. That's where the issue comes from. It was never getting into here. So we have a problem. It's returning the value exactly as is. That's why it's an issue. And the other issue is, how do we get it to run through this function? We can't convert it yet and break it up into parts, because that's what the whole function does, right? And we can't convert it to an absolute, because then you break it, because it's handled as a float. How do we create our own that doesn't use a float? Let's see. So x to the power of... What is the operator? I'm trying to figure out what that is. The bit shift, but we don't have bit shift surely. Pretty sure we don't. Let me just see what we can play around with. Why does it all work with float? Why would you use a float value for ABS? So we can't do the bit shift. Let's try this out quickly. We don't need square root. I think square root's already built in. So square root, we change x to I int. Oh, so square rooting a number. I want to actually see what happens. Whoa, literally square rooting a negative number will give you the positive when you times it by itself. I had no idea. I think we found our solution and our custom ABS function. Seems to work. So let's assume it does. Well, let's... do we assume it does? and waste time and trace it. I'd rather be safe and trace it to make sure. I'm just going to do IABS. We should have square root in the math script. Please tell me it doesn't use a float. It does use a float. Why would you do that? Am I gonna have to make my own square root function now too? To get the square root of something, it's... We're gonna need a for loop, a while loop, to try and find the square root. So we're gonna have issues with the float again, aren't we? Because float precision. Damn it. We need a custom square root function first. Because we're using a whole number. Let's try it first. Let's see what happens. INT times INT. Trace ABS INT. Let's do that. Let's see what happens first of all. Before we like try anything crazy. I'm gonna try several versions of this actually. Gonna give me an error. Fast, yeah. Let's try that. As a float, and let's see what we get. Of course we had to crash the creation kit. Crash our our compiler. I was gonna say Papyrus. There's a Papyrus compiler. Oh, Papyrus crashed! Cool, that succeeded. Shall we now see what we get? Please work. That'll be amazing if it does. no. Give me a sec. Sorry, we're back. Whew! I had to run out. And now it is playing Pokemon. And it was my 4th going to 5th day streak. I hadn't spun or caught anything. I literally just got it in the last minute. What are we even testing right now? Continue this. Oh yeah, we're testing our ABS value. Just want to see something. Alright, so what were we doing? Okay, so music stopped. GG. Now that's back. Okay, the next part is what's our ABS value? 3, 3, 17, 17. Okay, so it is unfortunately converting them to a float, which is going to be fine until, as you can see, we start getting to those larger numbers. What the hell is a -1 IND zeros? What? Okay, I've never seen that before. That's insane. Okay, so that's not working because square root is obviously that's not going to work. So we are going to need so we were looking for the quickest way to find the square root. I got a JavaScript function. Okay, so our function should be... So we need to convert this, obviously. We're gonna convert this to a int. Problem is square roots. I can see why they needed this as a float. I can see now why this calculation needed to be a... We're gonna do square root int global. Obviously we don't use the braces, we use begin and end functions. So we end the function and we don't have for loops, at least I don't think we have for. So this is going to have to be converted to a while. And then while int, because how did we start? We started this... No, never mind. Int I index equal to 0. Or we can just do I, can't we? Int I equal to 0. And then while I and what is the logic here? While I times I less than equal to the number. So while, from what I can read, it's while I times I is less than equal to int. That should be it. So while I times I less than equal to the number, then I plus equal to 1. So we're going to continue the loop. Oh no. I needs to be 0, and then we need to do I times I less than equal to int. Yeah, no, that's right. And then we're gonna I plus equal to 1. And then we have a check inside, which is if I times I is equal to int, return I. And if, and while. Else, we're just going to return the number. Because if we can't find the square root, we should just return the number, right? So this should be it. And then we can test it by doing like the square root of 9 in our (936). I'm just going to use random numbers. Let's see how that goes. No doubt we're gonna get errors. What? No errors. Amazing. Getting so much better at this. I just like completely converted a JavaScript function to this language. Like, I'm impressed with myself. That's how far I've come with understanding the language. Which is quite cool, which gives me a lot of hope for when I switch to JavaScript and then want to do like C++ or whatever. As long as I know how the functions work, I'll be able to get the same functionality, just obviously using the language specific functions and whatever else. But now let's just see if this will actually work as intended. Because there's a reason they did square root as a float. Because obviously there are a lot of decimals and stuff that you need to carry across. And the problem is decimals are only accurate to 6 digits, float digits. So I don't have much faith for this when I think about it. I just realized something. We're not echoing. We're not echo. We're not tracing what the value is. Chroma, hello. What are you doing up? Oh, it's still early for you. So I'm doing maths. How good is your maths? No. No, 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 no. 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 It's okay? So you can like do square root and stuff? Okay, you're gonna get to bed early? You can? What? Well, then you're better than me. Like, I can't remember the last time I had to do square root. It was like for high school and that's about it. You don't really use it in normal everyday today. I'm going to go to the shop and I'm going to buy myself, let's say, the square root of 9 packets of chips. Yes. It even took me a while to think of an example there. Yeah, bed early for you. And that's like bed early for me even. Like before, if I go to bed at like 3, 4, 5 in the morning. But I'm gonna end things off here myself because I like, have a feeling this is gonna drag out longer than it should. And I've already completed the function that I needed, which works brilliantly, but now I'm trying to handle negative values. And that's where I'm encountering issues. So this is what I've done, Achroma. Let's say you input a number 625,300,009 without the commas. It needs to be able to output it with the commas, and that works flawlessly. Square root of 9 is 3. That's right. That I know at least. The square root of 9 is 3. What's the square root of 36? It's gonna be some crazy number. Square root of 36 is 6. What? You knew that? You did it even faster than I googled it. What? You're on fire. How do you get the square root again? This is a number. Something to do with the power of, isn't it? That number times itself, right? So 3 times 3 is 9, 6 times 6 is 36. 148 times 148 would be 21,904. Oh, it's not that hard, considering the other things I've been working with today. So that's all it is. But then how is the square root of 148 12.165? What? Isn't it? There's something else going on here, isn't there? Oh god. Because square root of 6. Oh, this is if it's but that's not what the calculator is saying. The square root of 148 is 12.1. But then if you take 148 times 148, you get like 21904, 21,000. So is there like other laws that apply now? Because you have to do some crazy stuff like find the highest unique integer that goes into it, don't you? Or something like that. Let's go back to school, figure out how to do square root. It's weird that 3 times 3 is obviously 9, 6 times 6 is 36, that's a square root. Square root of 36 is 6. Is it the number, the highest number that can be multiplied by itself? Is that what it is? Square root of 81 is 9. Square root of 148 is 148 times 1. Yeah, but that doesn't make sense. Because when I do... Oh! I'm doing it the wrong way. Square root of 148. Yeah, the square root of 148. Oh. So 6 times 6. 36, the square root. Okay, yeah, I messed up. Okay, yeah. I'm trying to get the square root of 148. How do you get the square root? Because that's simplified. 3 times 3 is 9. But if I didn't know how to solve it, and I wanted the square root of 9, how do I know it starts with 3? Is it the highest value? Or would I use modulo here? I'm wondering. Or is it the amount of times you can put a whole number into it that it's squared? You just use Excel. I just realized something. Negative 1000 divided by 2, so to the power of negative. So how would this work, this function? If I'm using... Oh, the absolute value is the square root of a value times a value. You would flip it around basically. But I first need to make a function, square root. And I have a function here. But it's not quite working. I mean, it returns the square root of 9 is 3, which is correct, and 36 is 6, but square root of 148, because it couldn't solve it, it just returned 148, which doesn't really help me. Maybe I should have it as a float, and then take an integer, float I equal to 0. So what if you can't find the square root of a number? Let's go test this quickly. I updated it now. So yeah, today I learned about modular. Are you familiar with it? It's basically, I'm pretty sure it's a math function as well. Or might be just specific to computer science, but basically it's when you take two numbers and divide them and get the remainder of those two values. So if you add 10 modulo 5, 5 modulo 10, obviously 5 would go into 10 twice, and the remainder of that would be 0, right? Whereas let's say I had 5 modulo 11, you would be able to go into 11 twice, but you would have a remainder of 1. So modulo just gives you the remainder of that division. It was very useful with getting this function where it is today. Maybe our function works and I just haven't been giving it a try. Let's try our function. Square root ABS hours is IABS2. Imagine all this time it's been working. And we're going to use our function now, square root INT times INT. And let's see what happens. Break everything. Okay, so I'm going to change this back to an int. And then compile it. Why fail? Cast missing. What line? 158. Return I. Oh. I should be 0. Not 0.00, that's a float. Compile. Failed again? What? Types do not match. 158. 158. Return I. Oh, whoops. I even named it a float there, integer. So Chroma, when you do your accounting stuff, then I need to build you like apps will help my skills to help make your accounting easier. Now that I'm getting so good with maths, I don't think you'll ever need to square root something if you're doing accounting, right? I'm so proud of myself. Like I did this entire thing. Like this is how many lines of code I had and how convoluted and complicated this was, right? And that got replaced with literally just this. To get the amount of thousands, you just take your number divided by 1,000, provided the number is less than 1,000,000, right? And to get thousands, you just take your integer modulo 1,000. So that means how many thousands into the number, and whatever the remainder is divided by 100 is how many hundreds, because hundreds are not thousands. If that makes sense. So, yeah. It was pretty exciting! Did you manage to get a chance to check out Fallout 76 at the store, by the way? Did I do it now? I did it. Okay, let's see what our thingy says. ABS int, our int 0. 3. So far we're doing good. Ours is keeping up with Bethesda's one. Okay, they're both like fucked up royally there. Whoa! I was like, did a crazy number. It's doing its own thing. Yo! Okay, I'm done. I'm done. I'm done. I'm ending it here. If someone wants to display negative values to someone, they're crazy. Why? I'm done. I made the function work, and obviously I tried to flesh it out so that I can also display negative numbers, but I mean this is just getting crazy right now. So I'm done. The stock's being delivered tomorrow. And you can check that. Okay, cool. Hopefully that goes well. And that didn't play. I must remember to add the alert. That's why that's not working. I don't have any alerts on here. So all I need to do is add the hold on. I need to just grab that. Copy. Pasta. No. It's not what I copied. And then past reference, yes. You wanna try that again, Akrama? Should be fixed now.
This is Sparta!
There we go. Got that sorted out. Cool. So tomorrow I need to make my square root function work better. Because something messed up completely somewhere here. This is what I want. Encoding difficult mods, the Sparta. I guess. Cool, so I'm gonna end things off here. And I'll catch you around tomorrow. Tomorrow's Freakout Friday! Today! Later today! Can you believe it? Can't believe it. We're already there. Wow. If you get a chance, it would be cool if I see you there. Otherwise you must have fun doing whatever it is you're doing. And yeah, you must sleep well. And keep well. I'll chat to you again soon. See you soon. Night night.